Hello, I decided to buy one of these spindles with power supply and speed regulation. So this is advertised as a 500 watt air-cooled spindle with power supply, speed regulation, and I bought mine for around 60 something dollars, US dollars including shipping. If you're interested in getting one, just search for 500 watt air-cooled spindle, then they will show up. Doesn't matter where you search, you can find them on eBay, Banggood, AliExpress, Amazon, or wherever you like to shop. But of course be aware that the price might be different depending on where you live. And also be aware that there are two versions of the power supply here. One is the simple version I have here, and that's also the cheapest one. It's only got the manual speed control with a potentiometer here. And then there's a slightly more advanced version where it takes an input voltage of 0 to 10 volts, so you can control the RPMs of the spindle from your software. Anyway, I went with a cheap one. I don't need software controlled spindle RPMs. So for the money you get a spindle, supposedly 500 watt. It's air cooled with this small fan on the back here. You get a bracket. It comes with 4 screws, bolts, and if you take a measurement here, so the bolts are 6 millimeters, and the distance here 70 millimeters, and the distance here between the bolts is 20 millimeters. So whether you can fit that on your CNC or not, you'll have to check first, but maybe you need to make some kind of mounting plate or something. And then you get a power supply, so it takes the mains in directly here, and it should take anything from 110 volt up to 240 volt, and a small potentiometer here where we can regulate the speed of the spindle. And the spindle here got an ER11 standard colored chuck, so that means you can fit anything from an 1/8 of an inch tools up to 1/4 inch. I think it goes as high as 7 millimeters, but you need to have inserts that fits. Mine only came with an 1/8 of an inch insert, so if you need to use it with larger bits, then you need to get some more inserts here. I would say for me, I only use 1/8 of an inch, 1/4 inch, and I think I have a 6 millimeter as well. I think you can get as big as 7 millimeters, but that's kind of the maximum you can do with ER11. But anyway, as long as this is decent quality, it should give minimal runout. We'll test that later. So the first thing I noticed is that this power supply is very small and very light for being a 500 watt power supply. For comparison, I have a Meanwell 350 watt power supply here, and it is quite substantial compared to it, and it's also a lot heavier. So I think we need to open it up and have a look inside what's going on. So it's just got a couple of screws. Take this out. There's a sticker on the back we need to remove, but hey, never mind. We can slide this off. So yeah, this really explains why it's so light. So there's no mains transformer in here, so it has to be just pulse width modulation used to control the output. So according to specs, this output here for the motor should be between 0 and 100 volts. So depending on where you set your potentiometer, you should be able to regulate the output voltage here. But it's clear that it's not isolated from the mains, so that's a little bit not so great. It means everything here is actually connected to the mains input here, and even the potentiometer here. These connections here, so it's not just to make it pretty they put heat shrink on here. It's actually, you will get shocked if you touch any of this metal down here with these connections, because it's connected directly to the mains. There's no isolation. So if we take a look over here, we have two components. One of them here, that's a MOSFET, and the other one, I can't see what it says on it, but I'm pretty sure that's a diode across the motor output here. And then we have full wave bridge rectifier here, capacitor, fuse, and you can see the capacitor is 400 volts rated. So if we draw a quick little schematic here, so we have our mains coming in over here, and the first thing we go through is a fuse. So I mean, that's always good to have a fuse. And then we have these 4 diodes here making a full wave bridge rectifier. Our AC coming in here, plus and minus coming out. And then we have our filter capacitor here. So basically we'll have a DC voltage here. So in my case, I'm running 230 volt. That means I'm gonna get something like 320 volt here. If you're on 110, 115, 120 volt, you probably get half that. And then I believe it goes something, well, we're gonna have a diode over here. And our spindle motor. And then we're gonna have our MOSFET. Something like this. And then all this additional circuitry here, some controllers down here. That's clearly for the pulse width modulation controller. So that will open and close the MOSFET here. So basically the signal we see here is going to be something like this. And the duty cycle here is going to be regulated by where we set our speed control potentiometer. So if we say that's connected over here, that's our speed control. So as we turn it up to run faster, we'll just get more duty cycle on the signal here, and basically that will give us a higher voltage across the motor. So it is a fairly high voltage DC being pulsed across the motor. So of course the windings in the motor will smooth out these pulses here because they will be quite substantial, and the diode here will protect. So, you know, when you charge up a coil, once you let go, once the MOSFET here opens, then it's gonna be like a voltage surge coming out of the motor, and the diode here is gonna catch it, so it's not gonna destroy the MOSFET here. So a very simple design, but as I mentioned, it's a shame there's no isolation. So it means everything, you have to be really careful with all these connections here. Even the potentiometer connections over here, they will have mains voltage on them, and they'll sit at mains potential, so don't touch anything, and be careful with this potentiometer here because you do have exposed metal over here. So if you're gonna be regulating the speed, then, well, do be careful. Also, it's a little bit wrong that the casing here isn't connected to mains or earth ground to at least have some kind of protection. So very simple design, but a little bit disappointing. They decided not to have any isolation at all. Okay, so I've hooked everything up, and it's time to run the spindle, see how it runs. So I had to extend the cable a bit here. It's very short coming out of the motor, and it's worth noting that to get because it is a DC spindle, to get it to run in the right direction, if you flip the wires here, the negative or the black wire has to go over here. The black wire goes here, the red one goes here, and then the spindle will spin in the right direction. So usually one clockwise. And I have a meter on here so we can see what the power consumption is like. So right now we have the potentiometer turned all the way down. Let's try to turn it up a bit. Yeah, it starts spinning. It's very quiet at low RPMs. I do start to feel some vibrations here. That's not so great. Yeah, that's quite a lot of vibrations. See, the motor is moving across the table. Okay, I think I have to secure the motor to something so it doesn't drift like that. Okay, so I screw the spindle onto a piece of wood here. Hopefully that should stop it from moving around. So let's try again. And see if we can get a reading on the RPMs here. It's about 5,000. About 7,000. We're getting crazy vibrations. I will do like 10, 11,000 RPM, but it's vibrating like crazy. Okay, let's see what the power consumption is like. So it's about 0.7 watt in not running the spindle, just switched on. 27 watt. Watt, about 80 watt with no load. But it is very noisy with all the vibrations. So I want to do a noise test. So I think I'll do it at 50 centimeters, so about 20 inches away, and running the spindle at full beans. So it peaks out about 75 dB. Not too bad, but of course there's no load on it. But still, most of the noise just comes from the vibrations. So I think based on the size of this spindle and that it was only consuming 80 watts running idle, I do have some doubts whether it's actually a 500 watt spindle. You can see here for comparison, this is a 500 watt Makita trim router, and we can try hook that up and see how much it consumes. So this is gonna get a little bit noisy. Well, we can see here it went all the way up to 180, 200 watt. So quite a difference. So I don't think this is quite 500 watt. But let's see how much it consumes once we put it under load. Okay, I've set it up here for the next test. So I've set up a small dial indicator here, and it measures 1/100th of a millimeter. And I just want to do it first on here on the ER collet chuck, because it does appear it's screwed onto the motor axle here. I just want to see how accurate is that. Then after we'll try to do it on a tool in the chuck here. So, and I'm just running the motor off my bench supply just so I can run it really, really slowly. So let's try run this, see what it does. that's looking really good. That's only 1/100th of a millimeter out, so that's quite nice. And I noticed another thing. Look over here, see the wobble in the fan wheel here? So that's clearly not very well cast. And that's probably the source of all the vibrations. See how much it wobbles, it's almost a millimeter. That's not good. Okay, let me get a tool in, we can repeat this test. Okay, I got the small engraving bit in here, so let's try run the test again. So yeah, that's still looking very good. Still only about 1/100th of a millimeter of runout, so that's very good. So there's one more test I would like to do on the bench here before we move over to the CNC. I want to do a quick test on how much noise is radiating out from this power supply. I suspect it's going to be quite substantial because they really do nothing in the design here to try lower or prevent noise from radiating out. So I'll just be using a small scope probe here. I just take the ground wire, just do one turn and short it out. So that's usually a good instrument to pick up noise being radiated out. So let's see what happens. I'm holding it about 5 centimeters above the power supply here. Let's see what happens. Yeah, that's quite a lot of noise. Even at really low RPMs, it's almost 10 centimeters above, and we still have a lot of noise radiating out. So yeah, that's kind of what I expected. This is going to be very noisy. If you have any radio equipment or anything sensitive to noise, then you'll probably find that it's not going to be working very well while you have this spindle running. And I also expect much of the noise will be sent back out in the mains because there's no filtering on the input here. There's no choke, there's no capacitor, nothing. So it will also pollute your mains with noise when you run it. I have mounted the spindle in my small desktop CNC machine, so it wasn't too bad, but I did have to do a little bit of drilling and tapping just to get everything to fit. But this is with the bracket that came with the spindle, so it's all good, it's very solid. So I know it's tempting for those with a 3D printer to just go ahead and print a new bracket that will fit on whatever CNC machine you have, but I would strongly advise against that. First of all, you want your CNC to be as stiff as possible. You don't really want any plastic in there. And second is that you have to remember the spindle is gonna get hot. So it might not melt the plastic if you print a bracket, but it's gonna make it soft. And then the spindle is gonna start moving around. You're gonna get horrible precision. And worst case, it's going to destroy whatever material you're working in. Here, a quick look at the power supply. So I did add a small relay here to switch on and off the spindle. So this is getting a voltage from the CNC controller board, and that enables this relay and switches the spindle on and off. And I just have the speed control over here, manual, just holding it in a small vise so I don't have to touch it because, well, it is connected directly to the mains. I mounted a piece of wood and I've inserted a 6mm end mill so we can start doing some basic testing. But just before starting doing milling, let's try do some speed testing on the spindle, just see what the vibrations are like when it's mounted in the CNC. So low RPM, no problem. Here we're hitting some resonances. That sounds pretty bad. Luckily it doesn't sound like the vibrations are too bad at maximum speed. So it looks like the CNC helps controlling the vibrations a bit. So I'll start the job now, see how it goes. Okay, so it seems to be doing fine in wood. I'll just clean up the piece here, remove the burrs, but the finish looks quite nice. No problems here. So the spindle did get up to about, I think it was about 65, just a little bit below 65 degrees Celsius. And the maximum power consumption I saw was 110 watt. So now we know it can do the rough work. So let's try some finer stuff. So I'll try Engraving Circuitboard and we'll see how that comes out. Okay, I mounted an engraving bit and a small piece of circuit board. So let's do a test run on engraving a circuit board. So I will be running the spindle a little bit slower than I usually would, only about 6,000 RPM. It's simply just to get less vibrations. So, well, let's see how it goes. So let's have a closer look at the circuit board. I would say, it doesn't look bad at all. It looks very nice. I think the smallest traces here is something like 10-12 mil in size, so quite small. Try to zoom in a bit here. It's looking quite nice. There are some burrs here, but if you use some Scotch pad, you can usually get rid of all the burrs. Don't use sandpaper. So I'll say this came out quite nice. Quite happy with that result. I think that's enough testing for this video. So let's just sum it up here. On the positive side, I'll say it's cheap. I only paid $62 US for mine, including shipping. So that is quite cheap. And I would say it works and is simple to install and simple to use. And the spindle got very little run out, only about 0.01 millimeters, so that's quite good. However, on the negative side, I'll say the power supply is not isolated from the mains. It's got a lot of vibrations, especially at high RPMs. And I don't believe the advertised 500 watt. I never saw more than 110 watt being consumed while I was using it. So maybe you call it a 250, 300 watt spindle, but it's definitely not 500 watts. And the way the power supply is designed is going to radiate out a lot of noise. It's very unlikely they will pass any safety standards or certifications. I have to wonder if these spindle sets were originally made for some CNC manufacturer, but maybe they rejected them because of the high vibrations and maybe the slightly questionable power supply. So that's why they're being sold off cheaply. I can't say, it's just guessing. They have been on the market for quite a long time already. Anyway, if you have any questions about this spindle set, feel free to leave a comment and I'll try to reply to them as quick as possible. So I think I'll do a follow-up video where I'll try to see if we can do something about the vibrations, maybe remove that fan wheel and see if that helps. Maybe we can replace it with something else. Maybe we can just install a normal fan or something like that. I think it's worth looking into because the vibrations is pretty much the biggest negative I have with this spindle. But anyway, I hope you liked this review and give a thumbs up if you did, and don't forget to subscribe, and I will see you next time. Bye bye.